we have been talking about the unit circle, okay? And we know that there are coordinates on the unit circle, all right? And we've been working with very specific coordinates. There's like, what, I don't know, 12 or 15 coordinates we've been working with, okay? But it doesn't make sense that there wouldn't be coordinates in between those as well, okay? So what we're going to do today is make sure we can find this for any value on any number, not just our unit circle values that are standard unit circle values, okay? This box is no different than it has been before, okay? Really, it's all about the triangle, okay? If I were to draw a triangle in there, the horizontal distance is the X, the vertical distance is the Y. And again, this is our angle measure here. This is our radius of our circle. Okay, that's why they give us an R. And if we think about SOHCAHTOA, it's opposite over hypotenuse. Well, look at this. It's opposite over hypotenuse is Y over R. So this is absolutely no different than what we've been doing. Okay, it's just SOHCAHTOA. Okay, and CHOSHA-COW. Okay, just that. Okay, so that's what we're focusing on again. Okay, this little picture to the side is two ways to say the same thing, and it's already stuff you know. Okay, this is telling us what's positive in quadrant 1, which we know is everything, all, right? This is telling us what's positive in quadrant 2. We know that it's sine and cosecant, and everything else is negative. Okay, this is telling us what's positive in quadrant 3, which is tangent and cotangent, and everything else is negative. And then in quadrant 4, we know that it's cosine that's positive, everything else is negative. Okay, this is talking about the exact same thing. They're saying both the x coordinate and the y coordinate are positive. The x coordinate's positive, the y coordinate's negative. Okay, they're both negative. They're both the x coordinate's positive, the y coordinate's negative. That's stuff we already knew. Okay, so most of this is going to be based on just making sure your direction is correct. Okay, all right. So looking at example 1, we're going to try this, and again, this is the butterfly problem. Okay, so if you're following along with marking your problems, let me see if I can get the butterfly to paste in there. There we go. Okay, so the butterfly problem is the first two. Okay, the butterfly statement. Okay, so we are going to look at, now it's not letting me click out of it. All right, we're going to look at finding the 6 trig functions of the angle based on that coordinate right there. What's wrong? Yes, thank you. No, that's right. Yeah, because less than 0 is negative. In this quadrant here? Oh, yeah, you're right. Quadrant 2. I don't know why my eraser's not coming out. So this should have been a negative x and a positive y. Thank you for catching that. I was going too fast. Okay. All right. So we're going to determine the exact value of the trig functions of the angle. Okay. Basically, find your triangle. Okay. So I'm going to draw my triangle in there. I see it right here. Okay. So how many out is it on the x? 3. But did I go in the positive direction or the negative direction? Negative. So I know it's weird for geometry to have a negative side of something, but we're going to go with it. Okay. How many is it in the y direction? 4. Did I go positive or negative? Positive. So it's taking care of the signs itself. This is the angle. That's the right angle. I need to get that other side. How am I going to get that other side? Yeah, the Pythagorean theorem, right? So I'm going to go negative 3 squared for a leg, 4 squared for a leg equals r squared because there's an r on it. All right, what's 3 squared? 9. What's 4 squared? 16. What's 9 plus 16? 25. How do I undo the square? Now, technically, we're supposed to do plus minus, but if it's on a hypotenuse, it's always, always, always positive. Okay. Okay. All right. Okay. So yeah, and exactly, it's a 3, 4, 5. Did I really even need to do that if I knew that if I memorized the triple? You don't. Okay. All right. Now I'm also gonna label my opposite, my hypotenuse, and my adjacent. I don't know why my color's not changing right now. All right. So across from the ray or the reference angle is opposite. We know that across from the 90 is hypotenuse, and next to the reference angle is the adjacent. Okay. All right, so I got to find all 6. So sine of theta. All right. What is on the opposite? 4. What's on the hypotenuse? 5. What do we get for free when we have sine? What's the reciprocal? Cosecant, right? So I'm just going to flip it. And now it's being even stinkier. There we go. Over 4. I don't know why it's not right. Okay, then I'm going to go to the next one on the list, right? Cosine. It told us that we had to find the value of all 6. So we have to go through the whole list, right? They might be specific on some of them because it's going to be a Delta math assignment, and they might be more specific than that. But this particular question is wanting you to find all 6. Okay. All right. What am I looking for cosine on this one here? Adjacent over hypotenuse. What's on my adjacent right now? -3. What's on my hypotenuse? 5. Good. And then so who's the friend of cosine or the reciprocal? Secant, right? So I'm just going to flip what I had, and I've got the secant. It doesn't matter where the negative goes when we have a negative. It can be in front, or just it can float in front, stay on the top, stay on the bottom. It doesn't matter. Okay. All right. What about what's missing? Tangent. Tangent of theta equals. Okay. Opposite over adjacent. What's on my opposite? 4. What's on my adjacent? 3. And again, that negative on the 3, I could just float it in front. All right. Who's the reciprocal of tangent? Cotangent. Good. And the cotangent is going to be what? Perfect. Okay. So when we're in that part of trig, it's easy, right? We're just doing that piece. Okay. All right. What could make it more complicated is the numbers. This time on this next problem, it's the same problem, but they didn't draw the picture for us. We have to draw our own. Okay. So we're going to do a lot of drawing our own picture today. So let's read it with me as I'm reading it to you. Okay. So the point on the terminal side of an angle in standard position. Okay. Or the point is on a terminal side of the angle in standard position. That just means that you have an angle. Okay. And it's on the coordinate plane. Determine the exact values of the 6 trigonometric functions of the angle. So I'm finding all 6 again. They gave me the point. So I am going to go ahead and draw myself an XY axis. I'm going to draw this point. Out 2, down 3. I'm going to find my triangle. Okay. So my X value is 2. What's my Y direction? Yeah, it went down 3, right? And this is my angle still. This would be opposite, adjacent, hypotenuse. I still have to get the hypotenuse. What am I going to use to get the hypotenuse? Pythagorean theorem. So 2 squared plus -3 squared equals, I'm just going to call it r squared because it's technically the r. Whatever letter you want to use. Just don't use e's and i's, right? You can use a smiley face or a question mark if you really want to. All right, what's 2 squared? 4. Good. What's -3 squared? 9. Good. What's 4 plus 9? 13. I'm going to undo the square root or the square by square rooting. And good news, it doesn't simplify, right? So I know that that hypotenuse is square root of 13. Okay. Here's what I want you to try. Okay. I want you to see if you can get the 6 ratios. You will have to rationalize a little bit this time. Okay. But I want you to take a minute and see what you can do with it. Okay. Because you should be able to do this part. So there's the 6 ratios. Everybody find the 6. Everybody's finding them. Remember, you're using SOHCAHTOA. Okay, we're going to go ahead and check it over, okay, and see how you did. Okay. All right, so what did we get for sine? What over what? Good. Before I rationalize that, I would probably do the cosecant flip, right? Square root of 13 over 3. Just make sure negative is somewhere, okay? All right, I got to rationalize this. So I get negative 3 square root of 13 over 13. And I know delta math says something about making sure that you have rational numbers in the bottom. That means make sure that there's not a radical in the denominator, okay? All right, what do we get for cosine? What over what? 2 over square root of 13. So secant would be square root of 13 over 2. And I would rationalize this guy, which means I get 2 square root of 13 over 13. Okay. All right, what do we get for tangent? Negative 3 over 2, which means cotangent would be negative 2 over 3. Okay. Any questions on that type of problem? So they give you a coordinate point, you've got to find the values. Okay. And that one, what we coded as a butterfly problem. Okay. All right. The next ones are going to be the ones with the quadrant. Okay. This one. Okay. All right. So the next ones that we're going to talk about are the ones that are going to be the little frog problems. Okay. Let me copy that. Copy. All right. So the frog problems are going to start with example 3. Okay. This one? Got it? Okay. All right. So starting with example 3, all I want you to do is just read that one to yourself. Okay. These seem wordy. I copied and pasted them right out of Delta Math. Oh my gosh. My thing disappeared. So read it to yourself really quick. 30 seconds. Okay. So it's giving us a quadrant. Okay. We are going to find it's giving us a measure. It's giving us one trig ratio. We have to find another one. Okay. So it's giving us this information and telling us it's in quadrant 1. Okay. We need to find the cosecant of it. So I'm going to draw a picture of quadrant 1, and I'm going to draw a triangle in quadrant 1. Okay. This is my reference angle. If you want to call it A, you can. I guess they called it A instead of theta, huh? So technically, I should probably call it A. Okay. So secant, let's talk about this in SOHCAHTOA world. What's secant? What over what? Hypotenuse over what? Adjacent. So on my hypotenuse, I'm putting square root of 61. And on my adjacent, I am putting 6. Okay. I'm in quadrant 1. I know everything's going to be positive. I have to find the cosecant of A. Well, I'm going to have to get the opposite in order to get the cosecant. How am I going to get the opposite? What do I have to use? I got to use the Pythagorean theorem again, don't I? So, but this time it's leg plus a leg, right? Pick whatever letter you want, times the hypotenuse, or equals the hypotenuse squared. All right, what's 6 squared? 36. Okay, what happens with the square and the square root? They cancel out, so I get 61. How do I move the 36 to the other side? Yep, subtract it. So it's 61 minus 36. 25. How do I undo the square? Square root. Technically plus or minus. In this case, I'm going up. So do I want the plus or the minus? The plus. All right, now we're ready to do the cosecant of A. Okay, so cosecant is hypotenuse over opposite. So what's on my hypotenuse right now? Square root of 61. What's on my opposite? 5. The hardest part is probably the Pythagorean theorem part, right? It's not much different than what we've been doing. It's the way they're presenting the information. You have all the tools, okay? It's just how we're presenting it. Okay. I think that there's a couple more. Yeah, we're going to do one more together. Give you a little bit more opportunity to help me on this one. And then I'm going to have you try one on your own, and then we'll move it to a different quadrant. Okay. All right. So we've got sine of A is 24 over 25. We're in quadrant 1. And we're looking for cosine of A this time. Okay. This whole simplest radical form using rational denominator means don't leave a radical in the denominator. Okay. All right. So I'm starting with drawing my triangle in quadrant 1. Okay. All right. What is sine? What over what? Opposite over hypotenuse. So on my opposite, I'm putting 24. On my hypotenuse, I'm putting 25. Okay. I need to figure out what this is. I'm going to call it x. How do I figure that out? Good. So x squared plus 24 squared equals 25 squared. Because x and 24 are the legs. Okay, if you need help, look at the walls. What's 24 squared? 576. 25 squared. 625. Good. How do I move the 576 over? Subtract it. Okay, so we got minus 576. What do we end up with? Oh, we got to do that again, don't we? That's 11. 49. Oh, look at that. How do I undo the square? Square root. Do I want the positive one or the negative one this time? I went to the right, so I want the positive 7. Look at that. Nice Pythagorean triple. Right? Okay. Now we have to find the cosine of that triangle. Okay. So the cosine of this triangle would be the adjacent over the hypotenuse. What's on my adjacent right now? 7. What's on my hypotenuse? 25. Okay. All right. Before I move us out of quadrant 1, I want you to try one that's in quadrant 1. Okay. So everybody's going to take a minute. And you're going to try example 5 right now. Okay. So everybody's doing number 5. Give you about 30 more seconds on your own. You should have all drawn the picture. That should be done. Make sure you've done your Pythagorean theorem. Okay, let's check it out together. So I drew my picture. I know I'm in quadrant 1. So secant is hypotenuse over adjacent. So on my hypotenuse, I should have square root of 53, my adjacent 2. How do I get the other leg? Pythagorean theorem. All right, it does not matter what variable you use. Technically, it's probably y. So my legs would be 2 squared plus y squared equals the square root of 53 squared. Whatever you used here is fine. Okay. What's 2 squared? 4. Good. What's square root of 53 squared? 53. Good. How do I move the 4 to the other side? Oh, what do you get? Ooh, look at how nice that is. All right. Do I want the positive 49 or the negative one? Positive. That's going to change here in a minute, okay? Because I kept them all in quadrant 1 to make sure we got through quadrant 1 and understood that first. All right, so now I just need to find the sign. Opposite over hypotenuse. What's opposite? What's hypotenuse? Ooh, we don't like that so good. We got to rationalize that, don't we? So that made that one a little bit more difficult. So 7 square root of 53 over 53. Okay, any questions so far on that type of example? Before I'm going to make it a little bit different in the next one. I'm moving out of quadrant 1. Okay. Okay, so let's take a look at example 6. And these are still pretty similar to the ones we did with the coordinate at the beginning. Okay, it's just the way they're presenting it, it's a little different. All right, so example 6 says we're given the tangent is 33 over 56. We terminate in quadrant 3. We need the value of sine. So I'm going to draw my picture so that my triangle is in quadrant 3. Okay. All right, I have to be really careful on this one. Okay. So tangent is opposite over adjacent, right? So my opposite is 33. My adjacent is 56, but there's a problem. Look at the picture. Yeah, both of them should be negative, right? Because we did the 56 to the left and the 33 down. But think about what happens with this. A negative and a negative always turn positive. That's why it's looking like it's positive when it's really negative. Okay, and we see that a lot with tangent because we got a negative thing going on there. Okay, how do I get the hypotenuse? Pythagorean theorem. So 33 squared. And you could use 33 or negative 33. It doesn't really matter, right? Plus 56 squared equals, we'll go with r squared. All right. I think we need to break out good old Desmos, don't we? Because I don't think we've got a 33 and a 56. So I'm going to get out Desmos this time. I can't do that one in my head. Desmos. Here we go. All right. Maybe. All right. 33 squared. Help me out. You guys do it too. 33 squared. 1,089. 1,089. 56 squared. 3,136. 3,136. 3,136. Right? Now, you guys, you're in the second semester Algebra 2 at Trig. This is the advanced class. Do I really have to write that down? Could I have done that all in one line? Could I have done this? 33 squared plus 56 squared, which is 4,225. I could have totally done that. That's not what I wanted. This one. 4,425 equals r squared. How do I undo the squared? And then remember, on a radius like that, it's always going to be positive. I could have even done this. Instead of doing this, could I have set it up as square root of 33 squared plus, I knew that was coming, right? It's going to be the same calculation. Ooh, squared. Ooh, look at that. A nice triple. 65. Delta math works hard to get all those funky triples. Okay. So now I need to find the sine of theta. All right. What's sine in SOHCAHTOA world? Opposite of our hypotenuse. What's on my opposite right now? Negative 33. And what's on my hypotenuse? 65. Okay. All right. We're going to keep going. We're going to see if we can squeeze one more in before the announcements. Okay. You guys have done pretty good today. All right. But let's see if we can get one more in. Looks like I have another quadrant 3 problem. Okay. All right. Here's what I want you to do. I want you to see if you can get it set up. Set up the triangle. Watch your signs because it says you're in quadrant 3. So make sure you draw a quadrant 3 triangle. Okay, let's check it out together. Okay. What should I put on my opposite? But I went down, so what do I need to put in front? Negative. All right, what about on my adjacent? Good, because I went to the left. Okay. All right, what do we have to use from here? Pythagorean theorem. All right, so what are my legs going to be? 9 and 40. And it doesn't matter the order. And again, sign doesn't matter there, right? Because a negative is going to go away with the squared. That's 9 squared? 81. What's 40 squared? 1600, right? All right, what's 81 plus 1600? Yep. All right. Let's look at the square root button. Did that work very good? Is it a triple? Square root of 1681. Oh, look at that. 41. It's kind of fun to get those. All right. R equals 41. That doesn't mean we'll always get it nice. Okay. It just happens to be the problems that I picked. And apparently Delta Math worked really hard to get that to happen. All right. I want you to write down the cosine of that triangle right now. So everybody write down the cosine. All right, what do we end up with? Negative 9 over 41 because we had adjacent over hypotenuse. Okay. All right, I'm going to stop there. Okay. I will put some homework out there today. We will continue this tomorrow. I wanted to get to 11. We're not going to get to 11, but we'll keep working on it tomorrow and probably for another 2 days. Okay. And we'll squeeze some statistics stuff in there as we can. Okay.